and search on my screen. Okay, so today we're going to be talking about our next, let me see, I got the right thing. We'll be talking about an application of the percentile. Yes, I think the day before yesterday, we spoke about, what do you call it again? Give me 1 minute, let me just finish my setting. We spoke about like percentile, P50, 50% percentile, and then 75% percentile, things like that. Today, what we're gonna be doing is to do an application of this concept. Okay, we try to do an application of the concept. I'm trying to get my chat on right here. And make sure that you guys can see my screen. Yeah, I'm sharing this one. Perfect. Now got it, I'm ready. So an application of this concept. We're gonna be talking about something called box plots. It's a very easy concept. It's not hard at all. So as long as you remember how to find the quarters. Remember we talked about quarter last time, like the first quarter, second quarter, and third quarters. As long as you know how to get them, it should be something very simple. Okay, so let me not take too much time. The first thing we need to do is something called the 5-point summary. That means we need to find something called the minimum, and then the first quarter, the median or the second quarter, the third quarter, and the maximum. These are the 5 minimum, the 5-point things you need to remember. We need to get. What are we gonna do with them? The next thing to do whenever you have those things, you're gonna have to use some kind of a ruler, for example. Once you got a ruler, I like to say ruler, you need to use a ruler, something like that. So what I'm gonna be doing is to place the minimum. Suppose the minimum is, for example, this one. I'm gonna call it minimum. You're gonna put the minimum somewhere around here. I will say this is the minimum. I'll put M for minimum, for example. Okay, then you're gonna put the max, the first quarter. Probably supposed to look at the first quarter goes right here. So you do a little bit longer bar for the first quarter, a bigger bar. Okay, so we use a different color for them instead. Let me just do it one more time. First, you got a ruler. Okay, the extent you're gonna be doing to draw a line for the minimum. We find where the minimum is. Okay, we're gonna do an example soon. Suppose the minimum is over here, and I put the value for the minimum. Okay, the next thing to do is to put the value for the first quarter. Whatever you got for the first quarter, we're gonna put it there, but you have to put a longer bar for it. Okay, a longer bar. Then you're gonna get the median. The median number is the one that's in the middle, or the second quarter. Okay. I can answer a question about the test after class, okay? Give me 1 moment. So gonna be the first quarter right here. For example, the second quarter over there. And then after that, you got the third quarter. Maybe something somewhere around here. And then you need something called the maximum. So you do the same thing as you did the first one, a smaller one. Some people like to put a dot, but you can just put a letter bar. So then after I draw a line, just like this. Okay. And then you make a box on top like this. And this is how you call a box plot. Okay. Thanks you know about the box plot. This box plot looks like it look like to be what you call a bell shape. okay? If it's not a bear shape, so one that is not a bear shape, if you have something like this, then the buck bus goes like this. And then if you have a long bar over there, you're gonna say this is right skewed. Okay? Can be right skewed. Okay? And then if you have something that goes like that, you see, as you can see, the bound, the right left side is bigger, is longer. So that's called, you can say this is left skewed. Okay? If you look symmetric from one side to the other, you cannot say this is, you have a bear shape. Okay? Suppose you got something like this, like you are over here. So this is a bear shape, like this. This one looks so perfect, then you're gonna have the bear shape right here. If I can allow myself to draw the bear shape, it look like this. Some are like this. Okay? Something like that. Any question about that? Any question about that? Savannah, I will answer a question after class, okay? After, when I finish with the lecture about the exam. Now let's review what I just said to you. This is the only thing we saw today. We're gonna be talking about today. Something called a 5-point summary. You find the minimum, the first quartile, the second quartile, third quarter, and the maximum. This thing where we first quarter, second quarter, third quarter, where I do know how to do them from last class. Once we do the first quartile, we use a ruler, then we're going to do a visual presentation of the data that is called a box plot. Okay, we'll be talking about something called a box plot. If one of the side of the box plot is longer to the other one, you're gonna say this is skewed. It can either be skewed to the left, or it can either be skewed to the right. If it's symmetric on each side, we're gonna say this is a bear shape. I'm gonna talk about, this is just a quick introduction. I'm just saying right now. Let's keep going. Okay. So this one say, they give you something like that. That's an example. Okay, they say the result for survey asking how many boyfriend and girlfriend people have had. Okay, it shouldn't be low. Some people say 0 girlfriend or boyfriend. Some people say 1. Some people say 2. Some people say 10. Something like that. Okay, so take a time to look at what these things say about before I continue. So this is the data we have. First thing we need to know is to find the smallest data, okay, or the minimum. As you can see, the minimum should be 0. That's the minimum value, okay? Once you get the minimum, then just like we did last time, we can find something called, you can try to get the maximum. The maximum should is very easy to get the maximum, right? If you look carefully, right? But before I find the maximum, let's try to get the Q1 or the first median. So how do I get Q1? Where's my cursor? Okay, let's see. Okay, let's find Q1. Q1. Okay, how do I get Q1? Okay, so let's do that. We're gonna say how many data we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm gonna say the location for that, that'll be 0.25. Remember, Q1 is the first quarter or quarter times 11. So 0.25 times 11, that's mean half of that. That's gonna give you about, I think it's 5.5, right? I'm not sure. This is 11 data. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how much to give you guys? 0.25 times 11 for the first quarter. Okay, thank you. 275. I wasn't halfway. That'll be 275. Then you're gonna be round up. Okay. So usually you round it up. Okay. So if you round up, that's gonna give you 3. Okay. Now that's gonna be the third value. Which one is the third value here? You guys see which one is the third value? Is already in order for you. One, thank you. So that's mean Q1 is 1. Then you're gonna find the median. The median is the value that is in the middle. Because it's a small data, I can really see this one is the middle, right? Okay, it's divide this one in half and half. This is the other half on top, and then 2, and the other half at the bottom. Or I can just find Q2 if I want to, or for the medium. Okay, so that would, if you find Q2, I can also do the location will be 0.5 times 11. This one will give you 5.5. And that's round up to give you 6. That'll be the 6th value. So if I can like the 6, I see like if I do 1, 2, 3, 4, 5, 6. See that? This is this one. So as you can see, median is 4. Then if I the same concept, find Q3 as 6. And the last one is the maximum, which is 10. So what do we do with this kind of data? First of all, this is what I'm going to be doing. Try to remember the values. We have 0, 4, 1, 6, and some, etc. So what I'll do with those? What I'll do, first of all, what I'm going to be doing is to draw a ruler. I make a ruler for myself. This is because I'm doing by hands. If you have a scientific calculator, you should be able to do it easily. I think whenever you do the review, they should give you an idea how to do it. So I can just put this one as like, this go up to 10. I believe they go up to 10. I can say this is like 1. Let's see. Let's put like this one as 2. This is 10 right here. Half of what it is, that's going to be 5. And then I can say 1, 2, 3. Okay. Okay, so let me do it better now. So the reason I'm doing that way, so you see, I do try to do mistakes so you can see the difference. So you can do it on your own. So what some people can do whatever, you can do by 5, however you want to do it. Okay. So I can say if I don't want to take too much, I can say this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's one way to do it. And on the other side, if I don't want to use this kind of concept, I can use another one. I can also say, I do a ruler, and I put this is 0, and I can say this is 2, 4, 6, 8, 10, however you want it. It doesn't have a specific rule, okay? Now, if you're using large numbers, it's best to use like by 5 or by 10, by 20. That way you have enough room on your paper. Now let's do it. So let's look at the values one more time. The minimum is 0. So what I'll do, I'll put a bar here for 0. Some people like to put a dot, but that's fine too. You can just put small bar. Okay, for 0. This is 0. Okay. And after that, next value, it is the Q1 is 1. And Q1, because the Q1, I'm gonna put a longer bar for it. Okay, and this is 1 right here. The next one is Q2, which is 4. So I go up to 4. You put the same length of bar. Right here, same length. That's 4 right here. Then Alexa, the next one is 6. So the bar will be 6. Okay. And then the last one is 10. So I'll go over there and put 10 as a smaller bar. Again, there's options. People like to put dots for the maximum and the minimum, but you don't have to. So what I'm gonna do is 10 right here. You don't have to put the numbers. I like to put them. That's my style. Then what I do, I put the box like this. This is the interquartile right here, range. Right here, this is the interquartile range. Next thing I'll do, I'll draw a line from Q3 to the center, from the center of Q2 to the maximum. You know, the same thing on the other side. This is what they call a box plot. Okay, this is what I call a box plot. If you don't want to do the dots, some people can do something like, you can also do and start putting a bar for the zero, because it's just a question of style. Some people prefer to do that instead. They say, okay, you know what? That's different people, different style. Again, science. Statistics is not an exact science. Some people like to put a dot too. You can just do something like this and do the dot right here. I mean, if you want to, it's depend. Or it's depending on what it's depending on the way it is drawn on your exam. Okay, so you have different choice. Okay. Any questions so far?
What did the 1 represent?
The 1 is Q1. You see that? It's Q1. And this, I will get the Q1 like this. This, I will get Q1. The Q1, this one represent the 25th percentile. That's why I put 0.05, 0.25 is the 25th percentile. Is that which number is at the 25th percentile? If you have a whole dollar, you divide it into 4 parts.
Well,
okay?
on there it says 3. So how do we get 1?
What happened?
For Q1, right? The 0.25 times 11, right?
Yes, it give you 2.75. This one is called the location.
Okay.
The location of the value you're looking for. So after, once you get the location of the value, you go count up to 3. This is the first one.
Oh, okay.
Second, and then third, the third value.
Okay.
Okay, thank you for the questions. I really appreciate your question. Okay, so probably describe for some of you, then understand it. Okay, again, this is the location. That's not the number. That's the location. Okay. Any question about that? Okay. So let's quickly talk about something very important. I'm going to go back again to this one with some examples where I'm going to show you a couple stuff. As you can see here, we talk about something called interquartile. Interquartile, we spoke about it, you see, which is the RQR, which is going to be Q3 minus Q1. This is the last thing we did in class. And then this one right here, I'm going to put a different color, represent the interquartile. From here, this one represent the interquartile. Or you can call it also the mirror 50% of the data. Okay, because remember that whenever you have a dollar, you divide it into unique value. Everything is the same. Okay, I've got an on again. Everything is the same. Even though they don't look the same here in the graph, but this each one of them represent 25%. I know they don't look, but this is what it means. Okay, each location is 25%. So I'm gonna use a little bit different, a green one. That's mean here, oh no, not green. I don't see the green anymore. That means this one here is 25%. This is 25%. This is 25%. This is 25%. That's why I call them quartiles. Okay, and they look long, but there's been some more. So some of them got, got more data, something like that. It can happen. Okay, in that case, sometimes, as you can see, one of the bar is longer. If I can ask you just on this side, if I say what kind of, is it skewed to the left or to the right? Because one of them is shorter than the other one. What would you say? Is it skewed to the left or to the right? To the right, because the longest side is on the right side. So you can say this is skewed to the right. Thank you. Okay, thank you very much. Now let's talk a little bit about the interquartile. How do you find something? I'm sorry, not interquartile. Yeah, I'm going to talk about interquartile. You know, so I like to talk about outliers. When do you know a number is an outlier? This is the formula that we use. Whenever, how do you know a number is an outlier? This is the principle that we use here. Okay. So whenever you have a number that is beyond this expression here, okay, or after that expression here, we're gonna say this is there is an outlier. Okay, that's how we find. That's how we know whether a number is an outlier or not. Okay, so in our example, suppose I want to find m and m. So which one is the okay, let's find the interquartile here. Now, in the example that you did before, we had something like this. We had Q1, let me use a different color. We had Q1, what is equal to 1. And then Q3 was equal to 4, to 6. So that's mean the IQR will be 6 take away 1. Okay, or you can say this is going to be 6 take away 1. That's going to give you 5. Okay, that's the IQR or interquartile range. So how do you get m? M is equal to Q1, which is 1 in this case, minus 1.5 times 5. Okay, and then the big M will be 5 take away 1.5 times 5. That we're gonna know which one is an outlier. So let's see. So what that number gives you, 1.5 times 5, and then take away 1. How much is that? Anybody can do it? Use a calculator. So 1.5 times 5. How much is that using the calculator? Anybody? Participation? 1 take away 1.5 times 5. How much is that?
Negative 6.5.
6.5. Thank you very much. And then 5 take away. I'm sorry, not take away, plus. Why did I put minus 4? It has to be bigger. So 5 plus, that's going to be 7.5. Okay, thank you very much. That'll be 7.5. Okay, so this one is, for our example, this one is negative 6.5. And this one would be 7.5. So any number that is above 7.5 is considered an outlier. Okay, any number below negative 6.5 is also considered an outlier. Okay, that's mean we have an interval, something like this. For a number not to be an outlier, you have to be in that interval, negative 6.5 and then 7.5. If you don't want to be an outlier, you have to be inside this interval. This is not outliers. Okay. Now let me go back to our example here. So remember, based on the outlier, the number that we did. Okay, somebody start to cut and give me one moment. So based on that, the thing that we just did, which number I think I'll consider outlier here? Oh, this doesn't give you 5. Oh, that's a mistake. There's a mistake. You see something, I'll trust you, but I didn't look. This one doesn't give you 7.5. Anybody track? It's 13.5. Yeah, thank you. I just saw that too. So that'd be 13.5 here. Thank you very much. Okay, that's 13.5. Okay. Thank you very much, Marilo. We got the same idea at the same time. Thank you. That's 13.5. So as you can see here, all of these numbers are not considered outlier because all of them are between negative 6.5 and 13.5. So none of them are considered outliers. Okay, anything that is beyond that will be an outlier. Okay. So let me give you, okay, before I do an example, we can say, let me ask you this specific question. Based on that, based on this thinking, I can say is 12 sorry about my handwriting, an outlier. Can you say 12 is an outlier? Is it an outlier? No, that we know, because it's in that interval. If I got you 15, if I say is 14 an outlier. In that case, gonna say yes, because it's more than 13.5. Okay, so these are things we need to try to remember whenever you do it. So this little formula need to be in your note. Okay, so this is what happened. Whenever you're taking the exam, make sure you have notes with you, because I don't want you to go try to memorize stuff. So you have a little bit of notes on your side. You can use scratch paper. So you can use at least 2 sheets of notes. Okay. So, and then I have it on your side while you're taking the exam. So you have this formula written in your notes. Okay. So you don't remember them. I'm sorry, what did I say? So you can remember them, not you don't. So you can remember them. Okay. So if I say find the IQR or something, then you just look at the note, then you have to do it. Some people might think, oh, this is cheating. No, this is not cheating, because statistics is not an exact science. And then it's dealing with a lot of mathematical formulas. Sometimes it's best to use a little bit of note. If you don't, you're gonna end up confusing this formula to the other one. Okay, especially we're only doing like 4 months for this class. That means it's not enough for me to teach you statistics. I need more than that to teach you statistics. So therefore, you use a little bit of note to help you out. Make your life simpler, make your life simple. Take 3 sheets of notes or something, 2 sheets of notes, and then put in the notes before I take the exam. All right. So I already spoke about it. Yes, you can use notes on the exam. You have to use notes. I want you to use notes. I will recommend you to, okay? Right, Savannah? You don't need to round. You don't need to round. So any the number be above 13.5 or the number be a. So you want 12.5? No, we had 13.5, right? That's what we have. So if you do 5 and then 5 times 1.5 is about what? Hold on. It's 12.5. My mistake. I'm sorry, this is 12.5. 12.5. My mistake. 12.5. You're right. That's 12.5. I did in my calculator add 12.5. For some reason, when I look on the board, on the text, somebody put 13.5, right? Oh, no, you guys said, yeah, somebody put 13.5 and I got confused. All right, but on my calculator, I usually do it in my calculator, it's 12.5. We didn't round, okay? We didn't round. My mistake, let me fix it. Let me fix that. That's 12.5. Okay, let me use a different color for it. It's just simple calculation. So I just didn't pay attention. I didn't my calculator, but I just do once you guys what you have here. Hold on, let me just fix it. Keep coming like this. Okay, that's gonna be 12.5. Okay, they say this is equal to 12.5. We didn't run it, okay? It's also 12.5. This is just a simple calculation. All right. I mean, okay, so can we, yeah, so you got 1.5, that's it. Okay, thank you. And then, yeah. Let me see. It's just a simple calculation, guys. That's what I'm not supposed to teach you these things. Okay, you do 5 plus 1.5 times 5. That gives you 12.5. Okay, not 6 plus, it's 5 plus. All right. The median was 5, right? I'm sorry. When the interquartile was 5, right here, we did 6, take away 1, give you 5. That's how I got the interquartile. No, Q2 is not 5. It's the interquartile that is 5. You do this right here. The interquartile. We're talking about interquartile, IQR. That's why I give you 5. See that? There's going to be 6 take away 1. That's going to give you 5. You got it? Okay, perfect. Thank you for the questions. So let's just as I told you, something happened that people put other stuff on it. Okay, so it happened to be 1. So remember, it's IQR, which is going to be Q3 take away Q1. Okay, that's how you do it. Now, just do a couple things about outliers. Let me see. So this is an example here. For example, they say that they give you this example right here. They say that first quarter is something that is 109. Third quarter is 150 milligram per decaliters. So they want to know whether which one are potential outliers. Okay. So the first thing we're gonna be doing is to find the IQR. Okay, that's an example. What is gonna be Q3 minus Q1. right? Q3 minus Q1. So there's an error here. This one has to say not Q1, Q2, it has to say Q3. My mistake, okay? So that's Q3 right here. Because Q2 is the median. So that's gonna give you 150, take away 109. And then that's gonna give you how much? I think give you about what? 150 take away 109, how much is that? $150 take away 109, give you 41. Thank you very much. As you can see, give you 41. So now we need to find the first quartile. I'm sorry, you need to find the letter M and big M, right? Or I'm gonna say the minimum, the maximum. Okay, the minimum, it goes like this. It's gonna be Q1 take away 1.5 times 109. Okay, instead of putting Q1, I'm supposed to put 109, okay? No, I'm sorry, not 109. I wonder why the formula put everything at the same time. It's gonna be Q1 take away 1.5 times IQR. Okay? That's means that's gonna give you 109 take away 1.5 times 41, which is the interquartile. Okay? So once you do this math, you give it this, you give 47.5. Okay? You give 47.5. And when I do the next side as well, and this is what I got for the maximum, you give me 211.5. Okay? Now this is a question asking you, which numbers, when in these three numbers, which one you think is an outlier? Is it 38? Is it 200 or 225? Because this is the interval I want to have, which is 47.5, and then 211.5. That's the interval that's for those that are not outliers. So which one you think it will be the outlier here? Is it 38, 200? Oh, somebody say 38 and 25 are outliers. Thank you very much. So 38, because 38 is going to be on that side. So it's an outlier. And also 225 is on that side. Is beyond 211 is also an outlier. Thank you very much. 200 is in between, the 200 is fine. 200 is right here. Okay. Perfect. And then as you can see, 38 and 25 are potential outliers since 38 is less than the smaller number, and 225 is bigger than the highest number. And then if you have to do a graph for it, it goes like this. No, we're not gonna do any graph for that. So we're gonna express the idea with the box flux. So, and give me a moment, okay? My phone is on that battery. I can put this on that battery right now. Okay, before I keep going, does anybody have any questions? Before I keep going, anybody have any questions? No questions. All right, the following concept I'm gonna try to explain to you. Let me just, I can skip that because it's just lecture, but think about this one. Always know that the median is the one that's in the middle, okay? This one can be the lowest outlier because the minimum value is right here, okay? The maximum value is over there. So these are called our possible outliers. Sometimes whenever you have outliers for data, it's best to remove them. Once you remove them, the plot will have its rightful shape. Sometimes an outlier can be some extreme values that are there. It can be sometimes some mistakes somebody did, okay? It also can be like just like I said, one extreme value. Like for example, in a company, everybody is doing under $35,000 a year, for example, and then only one person, probably the CEO, is doing about $200,000 a year. So that $200,000 a year will be an outlier. Okay, or probably a rookie who just come to work and then having his yearly income as probably $25,000 a year, then that'll be also an outlier. That's the idea behind that. Okay, so this is quickly a summary. It's a box plot is a chart that visually display Q1, the median, Q3, and the potential outliers. Okay, so I'll just explain how to use the outliers already. So this is just a lecture for you to do. Okay, and then you say though you have to plot the potential outliers if there's any. Okay, just small vertical line segment, etc. for the median, just like we did earlier. And draw a box with base from Q1 to 2, Q3. This is we just did all of these things. This is how we do an outlier. Okay. Now I have a specific question for you right here. So this is like kind of like important right here. So if I have this following question, right here. If I say, what percent of students are below 83%? I know this look crazy, but why will you have, if I say something like, why will you say what percent of students score below 83%? Okay, by the way, I don't get confused, okay? These are the percent. This is a different type of exercise in which they say this one is, that's why I like to put the 82%. This one is like person right here. This is like 66%, 74%. Don't confuse them. It's like somebody's grades, okay? You understand? So you don't have to put the percentage if you want. You can say what percent of students are below 83 if you want to. So if you don't want to get confused, okay? I mean, what percent of students got below 82? What will you guys say? If I answer that question, these are students' grades, okay? Score in an exam. Suppose this is test test 11, something like that, okay? And these are the score of the students whenever I do the box of the student. So I'm asking you myself now, what percent of students got a score below 83? I can just say 83. I don't want to say percent. This is confusing, so don't confuse the thing. What percent of students have a score below 83? What will you say? 25%. Very good. Because we did say that earlier, the first box here is 25%. This one is 25%. This is 25%. This is 25%. And that gives you 100% for everything. Thank you very much. If I ask you also, what percent also are between 83 and 92? What percent have a score between 83 and 92? What will you say? 50%. Okay, 50%. Very good. All right. Any questions so far? No questions. All right, so sometimes it also can do a small comparison, but I can just, okay. So I can do a small comparison here. I can say, I don't remember probably which one has the highest variability, okay. So if I ask you a question, which city do you think has a bigger variation? Is it Provo or is it San Francisco? and temperature. Which one has a bigger variation? Provo. See that is because you see that it's wider. Okay, it's wider because as you can see, the graph is wider for Provo, even though they use the same ruler. The other one has a smaller variation. Okay, even though both of them look barely, what do you call it, barely symmetrical, barely a bear shape, even though they look barely, but one of them got a bigger variation than the other. Okay, if you remove the outliers here, if I would do that, then I'm gonna have a bear shape. Okay, closely bear shape. You know, it's like bear shape, but closely. All right. What I want to do now is quickly go over the review that we have online. Go do a couple of stuff. Then let me just stop sharing that for a minute. Last time, what I did last time, I did a mistake last time. I didn't save what all the notes that I did with you. But you see, you can look at the notes. I already put the video from last class for you. So if you look at the video, you can fill out the blank. Okay. So let me see. So let me just close that and show. I did save it. I say keep writing. I don't want to lose them. Okay, now I'm gonna share my screen with you, okay? Okay, so let's go share my, let's go online. Or anybody try to do the reviews online? Try to do some of them. But I want to point out something. I don't want you to think that the review is only what's gonna be in the exam, okay? So don't have that mentality because we're doing statistics and this is also a class that is a little bit challenging. So you may need to go think about the idea behind each concept. That's why I let you use, what do you call it again? Oopsie. That's why I let you use what you call again notes. Okay. So make sure you go you don't just stop only on what we teach in class, but you have to go beyond of what we teach in class. Okay. You guys are following me? So understand that the content of the data, the content, not especially the, okay, not necessarily it has to be exact word for words. All right. So let me get the notes. Let me go online. Give me a moment. So I'm trying to go online, and then while I'm talking, I got distracted. You guys are a student, trying to do any mistake. We're gonna go to modules. Okay, so let me just share my screen now. Now I can share my screen. So here we go. So I'm gonna go to modules. Okay, I'm gonna go all the way there to which one? The review, yeah, the review. So let's go to the review. This is test one review, and these are the answers. Okay, if you don't want to think too much, then you don't want to mess up your brain cell, then you can look at the answer if you want to. But there's got a couple stuff here. So these are the content that I need to focus on in this class. Okay, shape, variation, bar graph, pie chart, median, all of these things. Z-score, we spoke about them before. Left square, right skew, dot plus. We talk about all of these things in class. Okay. So for this one, I don't want to answer it now because I don't want to give away the answers. Let's look at this one here. This one say, describe the variation of the set numerically. Okay. So the question look a little bit weird the way they ask you, but you can think a little bit about it. So let's see. So if you had a calculator, you'll be able to get you'll be able to get what you call it again. You'll be able to get the information easily because I think and the review they do teach you about the calculator. I will show you one of them soon. But why not? Because I don't have a calculator. I mean, I don't have a scientific calculator in my hand, and then we're in class. So what can I do to find the variation? Describe the how can I describe that? Okay, so so what I'll do is the following thing. So what can I do here? So what I can do is to find the standard deviation of that. So it's they could describe the variation. So it can be like either, you know, the way they ask this question is a little bit weird. Whether they ask to find the variation or they have to describe it. Okay, but I would have to describe it. Let's see. So let me use my pen. Where's my pen? Okay, right here. So what I can do here is the following thing. Why don't you, with this, let's use box plot. Let's use box plot to describe it. That's one way. I can use other way too. Okay. So we first of all find the minimum. Will be 13. The maximum, that would be 19. And then we just find the Q1. Remember, Q1 is 0.5, 0.25 times the number of data here. You see how many data we have? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. When you find 5 by 11, I think we just said earlier that's going to give you 2.75, right? And that's going to round up to be 3. Am I correct? Oh, I don't see my shot anymore. Where's my shot? Yes, perfect. Okay, now I need to see my pen. Okay, so that's going to give you 3. Then this is 3, and then Q2. Okay, this is like odd numbers. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle value will be exactly what I need. Okay. All right. So it'll be 1, 2, 3, 4, 5, 6. This is gonna be right here. As you can see, got 1, 2, 3, 4, 5 on the left side, and 1, 2, 3, 4, 5 on the right side. That's mean Q2 will be 16. Okay, now let's find Q3. Okay, Q2 will be 0.75 times 11. And I'm just going to give you 0.75 by 11. How much is that? Would that be 8.25? Round up to give you 9. Thank you very much. So which one is the 9th number? This is 11, 10, and 9. That's me. That'll be this guy right here. That's going to be 18. So if you have to do the box plots for it, so how does it look like? Let's do a ruler. I'm going to go do ruler up to 20. Okay. This is 5. This is 0. This is 5. This is 10. This is 15. And then this is 20. Okay, I'll just do it, the rest of it. So there's no messed up here. So let me get my eraser again, and there is that little part here. So to avoid any confusion, why is my eraser? Oopsie, I lost everything. I shall see a straight line from there instead. Let me do a straight line. It's in that world. Here we go. It's not perfect, but you can do our best with this one. So let's see what we have. So we have the first value be 3, 3 somewhere on here, right? Closer to 5. Okay, that's gonna be 3. The next number will be not 3. I mean, that's 13 right here. Sorry, that's 30. We said 13, right? Okay, that's 13. So let me change that one a little bit. Give me a moment. So let me change that a little bit because I didn't pay attention because this one's gonna be too small. I cannot be able to see it. So let me do just a little bit bigger. But that's fine. Let's save it. Let's do that anyway. Again, you'd have to use all the way to 0 here because the way it is. So it's gonna be small. So I didn't pay attention to the small one. So 13 will be R1 here. Okay, that's 13. Okay.
What did 14?
What do you say 14? The minimum is 13, right? The minimum value is 13. Oh yeah, that's the Q1 is 14. Yeah, Q1 is 14. My mistake. Yeah, you're right. Q1 is 14. Yeah, because the third value. That's why you're trying to tell me?
Yeah.
So that's be 13 right here. Then you got 14. 14 for Q1. So that means they're really close to each other like this. Okay, somewhere like this. Now let me just try to do something. Uh, 13 right here. Well, my hands is messed up. Then 14 will be the bigger one. Okay. Then after that, you have 16 for the next guy, for the middle part. This is the median is 16. Then you have 18. It's a little bit closer to 20. Then you're gonna have 19. 19 going somewhere around here. Okay, somewhere around here. So I'm gonna do the graph. This is the box plot right here. And then this little thing right here. As you can see, this one look like you have a bear shape. See that? So I can say this is for the variation is you have a bear shape. Or I can say this is also symmetrical, barely symmetrical. I know because I put the numbers, you can also say this is barely, because you have a bear shape, you can say also this is barely symmetrical because you have the bear shape. Okay, so that's what I can say about the variation. And then some people can use other concepts. Okay, some people can find theoretical standard deviation, stuff like that. And then in which I wish I could use the calculator. I need to put that scientific calculator on my computer. That'd be easier for us to use. Okay, so what we can do also can use, let's use the example they have in the book, because I don't have a scientific calculator. So let's look at what they have in the book. Okay, so based on what I just did, I can say this is barely symmetrical. Okay, because we have the little dots closely the same height, the same length, and then this one kind of in the middle. Okay, and then by the way, this is 16. The bar should be kind of more in the middle right here. Okay, somewhere around here because it's 16. So it's barely symmetrical. So let's look at an example in the book. I mean, let's look at a video on that instead, if you can have a video. So let me just stop that for a minute. Stop, clear everything. So let's look at the drawing. I mean, not the drawing. Let's go to the module back. Where's the module? Go to modules. And then let's look at one of the videos. Okay, let's see what they do also. This is video number 1 for test number 1. Let's see what they do. Can you guys see my screen? Can you guys see the video?
Yes.
Okay, so this is what they do. Can you hear the talking? Can you guys see the talking?
No.
Okay, that's fine. So that's why whenever when I use Zoom, it doesn't sometimes it doesn't want to share the talking. But anyway, look at the picture. Look, let's pay attention to the picture. See here, he found the standard deviation by using the scientific calculator. So here, what he does, he uses a different method. That's why actually statistics is not an exact science. And that's why whenever you're taking the exam with me, it's not gonna be forcibly, some of them are not gonna be multiple choices. Because if it's multiple choices, then you're gonna have to miss most of them because the way the equation is being even asked. So what I'll do whenever you have an exam, I'll go and read it. Some people may have different approach to solve a problem. So earlier, we did it visually. The way he does it, he use what you call it, he find the standard deviation, which you have to use the scientific calculator, which gonna take a long time to do, but at the same time, the concept is the same. Okay, as you can see, he put that there, but look at what he have over there. Let me just show you too quickly. Let's go back to the notes and look at the answers. Let's go to modules. Just finding the answer is not enough. Let me show, where is the answer? Where is the answer? Where is question number 2? Exam test, yeah, right here. If you look at the test answer right here. So let's see what we have here. See what he did? So you see the data set is perfectly symmetric. Because where we in our head, we saw that it was barely symmetric. It's centered around 16. 16 will be this like the mean or the mode. Okay. So this one says, so the standard deviation is the best measure spread of variability. So it can, that's the idea behind that. Okay. You say, I'll input this data into the TID3 by doing this, then it's going to be able to get me the standard deviation. Okay. So so we did it visually, but he did it like Dan's trying to find it. So what we need to do based on what we see, first you're gonna find the either the mean or the mode, or the center, or either the mean, which I don't have a scientific calculator right now with me. I do have it with me, but not in the computer. I would like to do it with you, okay? But I don't have it here right now, okay? Then you should be able to, I mean, what you can do also, just look at those examples that he did and the school does for you. You can read them, okay? And the exam, I know the way I explained to you maybe visually, but you can talk about it. You can say this is barely symmetric. Then that should be enough for me, okay? Because sometimes I begin in all of these numbers, especially if you're not really good at using the scientific calculator, try to get those values, then that might be a little bit of problem, okay? But look at the videos. Look at the videos, the way he does them, okay? But I wanted to do it on your own because this is not my job to really go with you on the videos, on these reviews. That's why I want you to go over them and then you ask me questions about it. And I'll come with you and say, hey, this is what happened. You understand? You understand? I want you to go over these things on your own because this is a very massive class we're doing. It's not a little thing. So if you go over them by yourself and then you come with your questions about it, and I'm able to figure out with you, okay? Perfect. So go ahead and review those notes. Review while you're doing. I would suggest you while you're doing those review, use the answer sheet at the same time to guide yourself, because you don't want to spend too much time doing them. Okay. At the end, if we're doing the exam, I'm looking for that specific term. Okay. Symmetric. You understand? Because it's wanting to describe it. Okay. Usually whenever I describe something, sometimes I want to know what does it look like. Okay. It's symmetric. Okay. If it's symmetric, sometimes they might ask you to find the mean, the mode, standard deviation, all of these things. Sometimes it's good to know them. Okay. But the keyword here, if you describe it, that's a symmetric thing. All the numbers are enough, but this is the keyword I'm looking for. Okay. Again, this is not the exact exam you're doing here. It helps you to get the content of the exam. Okay. Make sure, again, this is important. Make sure while you're doing the review, you build your little cheat sheet for the exam, or you build the note for your exam. While you're doing the review for the exam, build the sheet for the exam. All right. You see even of the type of question here. In this case, he used a different concept by finding the standard deviation and say that on average, all the numbers are closer to each other by 2.49 on average. That's what I'm trying to say. And probably if you hear the video by second and hear him saying that on average, divide are closer to each other by 2.49. This is that symmetric. That's what it's gonna be saying. You understand? But if you want to care about the concept what we discussed in class, if you say to describe it, you want to say some expression like perfectly symmetric. Then you can add, this is the mean is 16, so, the mode is 6, whatever it is, the mean is 16, the median is 16, and then salvation is such and such. You can do that on the side. But the keyword is here is a symmetric. That's the keyword. If you find the keyword here, which is symmetric, then you got the full credit for it. You got the idea, Maria? We need to find the keyword. The keyword here is symmetry. They want to describe. Just describe something means that to explain what it is, not just giving numbers. Okay. If you don't understand, that's fine. Take numbers, but describe means that to express what it means, to give a definition, to give like what it look like, so you can have a picture of it. Describe call your visual sense. Are you with me? Okay, so go look at them. Look at both the videos. Look at both the videos, the everything. Then ask me question. Next week you can answer after class. Okay. So I'm gonna be stopping here. If you have any question, please stay after class so we can talk together. Okay. By the way, we're having the exam next week. This I forgot to tell you, I'm gonna do the exam quickly. We have 2 minutes, 3 minutes. This is how it's gonna be. I'll be here Tuesday with you. But the thing is that the exam should be available when? Let's look at it here quickly. I'm sorry, but I didn't talk about that one quickly. So I just said I was gonna talk about it. If you go to the announcement, if you go to, yeah, that's good. So the exam should be available February the 2nd. I think it's available today until Tuesday. Okay, you hear me? It's due Tuesday, February 7th. So the exam is available right now. You should wait to the exam right now. That's been Tuesday. We don't really have a class. You're gonna come to me on Tuesday if you have any technical questions. Okay, if there's a technical issue, then you can talk to me on Tuesday. But I'll be here, but just in case if you have any specific question for me, okay, any technical issue. But this will happen. The exam is available now. You can do anytime you want. Remember, you only have one trial, so take your time to do it. Okay, take your time to do it. Don't rush on it, and then you should be fine. Okay. Enjoy the rest of your evening. If you have any question, please stay. You guys are dismissed now.